Instead of having hours of things to look at. Okay, so I'm going to start Visual Studio. And I'll probably zoom up a little. So I did start the recording. So we talked last time about selection, which is where you make decisions based on an if statement or a switch. Switch is a lot more limited. Some of you tried to use it, and it doesn't like doubles, for instance, like with the grades. It just doesn't like that. And part of the reason is that with a floating point, it's really hard to make an exact match, and the switch can only deal with exact matches. So this time we're going to deal with the other thing. Computers are really good at making that kind of branching decision. Another thing they're really good at is doing the same thing over and over again. That's what this is about, for loops and while loops and looping things. And you'd be surprised how often you need to do things over and over again. So, if Visual Studio ever launches, there we go. I will zoom up. I don't know if you need that for this, but we'll do the usual start. File, new, project. And we'll do console application. And I will call this one, I think, for loop example. There's a couple of pure exercises that I did, one for loops and one for while loops. So we might intersperse those. It'll make it so I don't talk the whole time. Give you a little bit of practice. So I'm going to call it for loop exercise. You can put spaces in these, but if you do, you might notice that what it does is it puts underscores between the spaces. And this always becomes your namespace. You can actually, I'm not sure if I ever said this, but you can live without a namespace in your program. You could eliminate the namespace if you really wanted to. You have to have a class, right? And you have to have the main. But the namespace is optional. It's useful because it, yeah.
What's the difference between a class and a namespace?
A class is an object. It's basically, when we get towards the end of the quarter, we'll spend some time on objects, and object-oriented programming. So a class is a description of an object. If you were building a point of sale software, for instance, you probably would have objects like customer, product, sale, message even. There'd be all the different things that make up that point of sale would be developed into classes, which lets you group together your code into meaningful chunks, basically. Namespaces are for grouping classes. So we're never going to make one this sophisticated in there, but you might have a namespace for your main program objects. You might have another namespace for all those objects that are designed to work with the database, the data layer. You might have another set of a namespace for objects that are meant to work with, like your ATM or your, payment system. So namespaces help group things together that belong together, and they let you organize a further higher level of organization. Does that make sense? So classes are, at this point, they're kind of mysterious. They typically have this teal thing, but we've been using some. You notice the console is teal. That means it's a class. Somewhere in the .NET code, somebody wrote a description of what the console is and what it can do. That's a class. When we use, today we're going to use random. Random is a class that does what you think it does. It produces a sort of random number. What other classes have we used? I showed you math. When you do math dot, and again, math is a class that they wrote that is really just a series of math functions that we've made available to you. Are there any other classes that we've used? I don't think so, but I'm trying to remember.
Windows would be a class.
Windows is actually like thousands of classes put together. um, and probably a whole bunch of namespaces. I mean, Windows is a fairly complex thing. So we'll do, and each of these is like a library that consists of many different, sometimes it consists of namespaces too. I mean, sometimes they're divided up into namespaces. Other questions? I mean, these are good questions, getting a context. We will, as I said, spend some time with classes when we talk a little bit more about object-oriented programming. Everything in C# is an object. Literally everything is an object. That's actually, remember, double and int. Even they are classes. Even they are objects because you can do int dot and it has stars. In traditional languages, like even Java or C#, that doesn't exist. Integer is just a number. It doesn't have any methods or properties. It's what's called a primitive type. But in C# there are no primitive types. Even the types are classes. So it's probably the most object-oriented language ever developed. It's even more object-oriented than Java, although they're close. They're really close to each other. That being said, as I said, we're first getting the real basics, the stuff that applies to every language, object-oriented or not. Actually, before I do anything in main, let me do a quick comment. So this program will explore, I'm not sure that's the word I want, but repetition with, that's not how you spell repetition. Is that right? I have a master's in literature, but I never learned to spell.
Totally different skills.
Yeah. And you might also put, I guess, before I do that, today is the something or other. What is today? 28, 16, 22, 18? And again, this is just a good idea to do this. So to date it and sign it. It also, although your code is always in your under your name in the, when you submit it, it's still useful sometimes for me. So loops. How many of you have worked with other languages with loops, like JavaScript or something? 1, 2, 3, a couple of you. All right. The loop I'm going to show you looks exactly the same in C#, C++, C, JavaScript, Java. It looks exactly the same. It doesn't look the same in Python if you're going to do that. But with a loop, so let's just do for, and I'm going to give it a variable to be used as a counter. You can name this variable whatever you want. Typically, it's like I or X, because it is just a counter. You could even call it counter if you want. Int I, and then you do the start of the loop. This is where the loop is going to start. We're going to create an integer called I that will be used as a counter. We're going to start at 0. I do a semicolon, and it's in the parentheses. There are like 3 arguments. There actually can be more arguments, but we're going to limit ourselves to the 3. Then you have to say, when does the loop end? And I'm going to say I is less than or equal to 10. So it will loop as long as I is less than or equal to 10. right? So it basically will loop from 0 to 10. And then, this is an operator you haven't seen. I'm going to do I++. Does anybody know what the plus plus means?
Go up and add.
Yeah, it increments. It's an increment operator. It means keep adding one. Every time you do a loop, add one. Does that make sense? So we're basically saying we're starting a loop at 0. We're going until it is less than or equal to 10. As long as that's true, we'll keep looping. And each time we loop, we'll add one. Okay. You could do minus minus too if you want to count backwards. Right? Minus minus it decrements. That means it subtracts one each loop. So this is like an if statement. You do not put a semicolon here, but you have a couple of curly braces. Once again, you could, if you only have one argument in the loop, you don't have to have the curly braces, but I would suggest you always use them. Because if you forget them when you need them, you'll get unexpected results. So let's do, what do we want to do inside of our loop? We could just show the numbers. Not very exciting. Or we could just repeat. We'll do something later. We'll do something inside of these that makes sense. Let's just run. Oh, and then I need to, outside of the loop, I'm going to drag in my text. I need to quiet my phone too, I think.
How did you do that?
You remember I had drug it over to the toolbox? So hopefully it won't, because it alerts every time a news thing comes through or anything. All right. So I'm going to run it, and then I'm going to run it another time, and I'm going to show you a little bit of something that's really useful in debugging. Hopefully it'll work here. I'm going to start. It's going to be very boring. Run. Oh, there it goes. And if I want to zoom up, I can, but you can kind of see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, press any key to exit. If you want, I can zoom that bigger. So what kinds of things would make, can you think that you would need to loop in a thing? You could do it, I mean, if you think about it, like if you're calculating interest, if you're doing math, you would want to figure out how many years you would be calculating the interest for. We could do that in a moment. You could be calculating, I mean, as I said, it's amazing how often you have to loop. You're right, if you wanted to do prime numbers. That's a complicated algorithm, although there's a simple, thing is, I might have done this as an exercise. There's a simple equation that will do 40 prime numbers in a row. It's an anomaly, though, because it can't predict any of the prime numbers before the sequence or any after. It only predicts 40 in a row. There's a lot of things you could loop for. One of the things I want to do right now is I'm going to put a little red dot in the gray over here. Does anybody know what that does? It creates a break. So when we run this, the code will stop right here, which is right at the beginning for us, right? So it's a little red dot in the corner. It's a break. This is really useful when you're trying to figure out why something isn't working. Something that isn't crashing the program, but you're getting a bad answer or something. So having put the break there, what I'm going to do is I'm going to run, and it just breaks. Notice that there's the little red dot now has a orange or yellow arrow inside of it, and the cursor is right here. If you do a F11, so that's just 11, it goes to the next statement. And notice that you can put your cursor over there, it says I0. And if I look at the I here, it says 0, and if I look at the I there, it says 0. I press F11, it goes here, and it goes, then it goes F11, it goes into the code, it looks at that, it says that I is equal to 0. I'm going to do F11 again. Notice it goes back to the top of the loop. This time it's going to increment by 1. So when I press F11, I now, when it looks at that, is equal to 1. And when I press it again, so it goes down in here, and so I, of course, is still equal to 1. And it goes back to the top. And it will increment. So if I press F11, it goes beyond the increment. I is now equal to 2. And you can kind of see that. I'm just going to do it for a few times. So I'm just curious. I'm at 6, 7, 8, 9. Am I at 9? No, I'm at 10 now. So this is the terminal condition, right? I is equal to 10. That means that we're, well, less than or equal to 10, so we have one more loop. It's still within the range because it's equal to. So it goes through here, writes that. Now when it increments it, I is equal to 11. That is no longer, it's no longer true here. Notice it says false. And what that means is it will pop down out of the loop. So it just keeps looping until this condition is no longer true. Does that give you a good sense of how the loop works? This isn't hard. It's a little bit strange syntax at first if you've never done it, right? With the semicolons inside the thing and the 3 arguments.
Is it always, is it always 3 arguments? How many arguments can you have?
So you can have some multiple conditions.
How do you do that?
Oh, I'd have to look it up. It's been a long time since I did that.
Okay.
You can also, I think you can have multiple iteration things.
Okay.
So then you'd have to have multiples over here. To me, that doesn't make sense. It makes more sense to do an internal loop or something. You know.
Can you iterate by numbers other than 1? Or not iterate, increment by numbers other than 1?
Yes. So let me kill this. Let me do the same loop so we have both of them here for examples. So if you don't want to, you could say plus equal 2 and it will iterate by 2s. Plus equal, anybody know what that means? That's something I wasn't going to introduce for a while, but you can do that.
Go up by 2?
Yeah, so it's this number, it's the equivalent of, so I is whatever I is, right? It's equivalent of I equals I plus 2. So it's just a shortcut. I plus equal 2 is exactly the same as saying I equals I plus 2. Does that make sense? Yeah.
You know, if you put with your constant right line I, you could do I plus plus in there, you'll count by 2 also.
You could, although it wouldn't. Yes, actually, it would probably. Actually, the right line wouldn't iterate it though.
It does.
It does. It actually iterates
It goes
the
0,
I.
2, 4, 6, 8, 10.
Oh, okay. I was thinking it wouldn't in the right line, but I guess it is because it's still just the raw variable in there.
Not because each one is adding 1 to it. Before
Right.
0.
Well, yeah, so if you did plus plus here, it would be incrementing it in two places.
Instead, oh, putting plus plus with the I in there?
Yeah.
Okay.
It would increment up here and it would increment in here. The other thing, the plus equal 2 is actually going to show just odd numbers. I can show you because it's
So you
1
got
plus
1 plus
2.
2, 3
Yeah.
plus 2. Okay.
So if we run it, whoops, I still have my break. So actually, it did even numbers. I'm
Because you
wrong.
started with 0.
Because I started with 0 because I didn't start with 1. Yeah. 0, 2, 4, 6, 8, 10. The reason I started with 0, we're going to use these loops a lot with arrays in the near future, and arrays always start with 0. But you could start with any number you want, and you can have whatever condition you want. It is possible to create an infinite loop. Let me do an infinite loop for you.
I think I accidentally did that when I was practicing with
Yeah.
I kept going.
So I'm going to do I is equals 0, and I is greater than 10. Let's just say I is greater than 0. And we'll start with 1. So this will go on forever. Now, it's not so fatal in this because I can kill it in Visual Studio. But if this was happening in a thing, the only way out is to close the program.
Is there some point where it will actually run out?
It may throw an error when it gets up into some billions because we'll be overrunning the length of the integer.
Yeah, that's what I was wondering.
This actually can be kind of fun if you were trying to create one of those screens or a movie where you have all this stuff scrolling up and things. I think sometimes in the movies, that's actually what they do is they just create a loop which moves the scrolls the thing. Because if you look at it, it's all sort of gobbledygook on there. So infinite loops are things that generally you don't want to do. And they're just, as I said, it could just be, it's usually if your condition for termination is never met, right? So you always want to make sure that it is met. I'll show you how to do a while loop in a bit. A while loop, you can create a loop that will last as long as you want, right? First, we'll focus on this stuff. A couple of other things I want to say about this. Again, this isn't super hard, although, they take a while. And you can have for loops inside of for loops. I am going to, I guess let's do it in here. Let's declare a couple of variables. And, well, let me unzoom too, because it's bouncing around. I just want to show you can use variables for this. So let's do int number. I'm going to say equals 0 initially. And then I'm going to say console right line, how many so let's do trying to think of something more interesting to do than just output numbers. We could just do kind of an exponential. Each number times itself. How many times do you? It's not a very useful prompt, but so, and then I'm going to do number equals int parse, and we could do a try parse if we wanted, which would be a good idea, but and then console read line. Now, a couple of things, kind of like with the switch. When the criteria here needs to be an integer, right? It can't be a double, a floating point. It needs to be an integer. It might work with a double. I don't think it will.
Well, if we change it to double I to 0, would it work as a double then?
Well, I do not know. Let's try it.
All right.
I don't think so, but it's not drawing an error, so it might. I didn't do anything with that. Whoa, wait, I still have the infinite loop at the end. It worked. It worked as a double. So I guess I'm wrong. But doubles are usually you want an integer.
Well, I was just thinking if you wanted the number equals 0 to be a double instead of an int.
It seems to work. But almost, you rarely see a double, and I'm not sure why you would want it, because they're just a counter, right? They're just counting how many loops, and loops are always whole numbers. So it makes more sense for it to be an integer. So I'm going to do just another loop for, in parentheses, int equals, do we want to start with 1 or 0? Do either. Int equals 1. Int is less than or equal to number. And then I plus plus. Okay, and then I think, oh, int I. And I was writing I and it was putting int, but because I forgot to declare it at the beginning. Here is something that I should explain too. Why can I use I here and here and here and it's not complaining? Anybody have a clue? Yeah.
Because each time it's going through and then it's becoming something, you just using it as a counter in a part.
Yeah, it's a thing called scope. Does anybody else have a? So scope is a variable has the scope of the block it's declared in. So number is actually accessible anywhere in the method because I declare it in the openly in the method. But I is declared in the for loop. So this I is only visible inside the for loops, and then it's discarded. So when I declare I here, it's a different I than this one because it's a different loop. When we start talking about methods, this becomes really important. You know, what is the scope of a variable? And the scope means where is it visible? Where does it have its value? You know, where is it accessible? This I is not accessible down here. This I is, you know, this I is, these are local to the loop because these are blocks, right? They're declared in this block and that's the only place where they're visible. If you don't like that, this could be X and this could be Z, you can name whatever you want, right? Number, on the other hand, is accessible anywhere because anywhere within the main, because it was declared, you know, openly within the block of the main. That may be a little mysterious, but as I said, when we start breaking things into methods, that becomes important. We'll talk about it more. Questions on it, though? The big rule for scope is that a variable has the scope of the block. It's, you know, it's declared in. If I declare another variable inside of here, I won't be able to see it elsewhere outside of that block. I could show you that if you want. In here, I was just going to say number times equal number. Anybody know what that does?
Squares it.
Pretty much, yeah. So it's basically the number. This is as number equals number times number. So yeah, it's square. But it'll kind of move exponentially. Just as an example, and then I'm going to do console right line number. If I were to declare something in here like int number 2 equals 0, this has no meaning in here. Oh, no space. See, it's happy there, but if I go down here and try to do number 2, it sounds, never mind. Notice it's red underlined. This number 2, because it was declared inside of this block, can't be seen here. It doesn't exist for this one. That's all I was trying to show you with the scope. And that's good, because you can keep things distinct from each other. But it's also can be bad in terms of if you get confused about it. When you're trying to access a variable that doesn't exist. Or worst case scenario, you declare a number out here, and then you do int number here. What would happen? Actually, it doesn't like that. I'd have to do it in another method. It won't let me redeclare it. If you're doing it in between methods, and we'll talk about this later, if you have an int number here and you declare it somewhere else, the local one always has precedent over the other one. But it isn't letting me do it in a loop. Let's see if this works. Build errors. What are my build errors? Int I equals 0. No, that should be okay. Oh, it is giving me, it shouldn't give me errors on that. Oh, I'm missing a curly brace, that's why. Thank you. I deleted that when I deleted the number. Because it didn't make sense that these, but they were in the same scope because they were inside the other loop because I hadn't closed it. Okay, let me zoom. All right, so how many times do we want to loop? Let's not make it too excessive. Let's just do 4. Okay, so this is the, we did 4 here. So the first one is 4, right? Because it's just 1. So it's just 4. It's 1 times, what's the number times, well, actually, so we do 4. That's what I am. Then it's 16. 4 times 4. And then it's 256. And then it's 65536.
Yeah. When I tried doing 3, I ended up with 6 different numbers, and the last one's a negative.
Yeah, I got that with 6 as well.
Let me try that. Why would there be a negative?
I don't know.
Unless it's by intent, it's positive, right? Does it make sense?
Yeah, it
It seems
doesn't.
like odd numbers end up with a negative at the end.
Yeah.
Why would they end up with a negative? Times equal number. Oh, it's possible, but it shouldn't get that far. I ended up with a negative at the end of that too, although,
And then 3 times gives you 6 numbers.
4 times the last time is 0.
That doesn't make sense. Why is that doing that? What is in our thing is doing that? 81 is correct, right? 9, 81, 65, 61. That's actually only all the farther it should go.
And when you put in for 2 tons, you end up at 2, 4, 16, 256, and then 65, 536. And then 0. When you say you want to loop through it twice. Yeah. How do you say 2 should go?
So what we did? We did I equals 1. I is less than or equal to the number. I plus plus. So number times equal. Oh, you know what's happening too is we're also incrementing number. So I think we're not only getting the exponent, we're also incrementing it each time. But I still don't know how that ends up in a negative.
And if you're just squaring it, it should only give you a couple answers instead of 6, and the last one being 0.
Right, it should only loop that many times. Well, this is where we can do this. I'm gonna see if we can figure out what's going on. Not that the loop is the main point, but I'm going to just loop through there. So 3 is one of those numbers that's problematic. So I is equal to 1, number is equal to 3. Okay, so number is 3 times equal number. So when I go down there, it's 9, which is correct. We write the number, which is 9. We come back up, whoa, on F11, not. So F11, we come back up here, it increments it to 2. So the number is 9. It's still, I is 2, so the number is still greater than. So less than, did I do the number wrong? It's true that the number is less than or equal to. I don't know that that is true. I is 2.
It should almost be.
Yeah.
The number keeps going.
You know what it is? Yeah, that doesn't make sense. This is the problem, I think. And I think where we get the negative numbers is because it's going out of bounds for an integer. And what happens when it goes out of bounds, if it doesn't throw an error, it just gives you garbage back. Let's change this. So we want int I is equal to 1.
You might need 2 variables.
We might. We're actually not incrementing number.
We are in the bottom part.
Well, no, we're here. We're just number times number.
We're just changing it on top.
Right. It changes it to this, so it's always this is always less than. So let's just do. We could do this. Not that it matters, but actually this is kind of useful for. So the number of loops versus, because I think we're constantly changing the condition up there. So console write line, enter the number to get exponents. I don't know. I'm just trying to think of something to say there. That's probably not a good prompt. Number 2 equals console read line. And then what I'll do is we'll just do number two. Now, it still may overrun an integer at some point. So let's try that. I'm going to get rid of this, see what I get. So it's going to ask, I'll show you it again. So it's going to ask how many times do you want to loop? Let's say 3. And the number of that we want to get our exponents from, let's say 4. Oh, you know why? I know why. Because I still was printing number. I'm also going to do I'm just going to make a space between it and the next loop. All right, so if I want to loop, let's say we want to loop 4 times, and the number we want to loop with is 3. So that 9, 81, 65, 61. Still got an extra number, don't we? So 9, 81. I think these are correct, but why do we have a 4th one? Oh, I said or equal. Well, I said 4. That's 1, 2, 3, 4, 5.
No, the number 3.
The 3 doesn't count.
Oh, the 3 is what I entered. Yes, never mind. I can fix that too, so it's a little clearer. We'll just do a console right line here to get a space too. So it did work. And if I run it again, this will be a little clearer. How many times do you want to loop? Let's say 5 times, and let's do 3 again. Now the minus here, I think, is because we're beyond the limits of
So if I choose, I want to loop twice with one for the exponents, I still get 5 numbers. I get 4, 16, 256, 65, 536, and 0.
when you're looping what twice?
I loop twice with the number to get exponents is 1.
So it should all be 1.
Right.
So we loop twice, we enter 1. I just get 1, 1.
And let me check. Let me check.
Can I see your,
Yeah.
let me see where I'm.
Let me unzoom so you can get a little more of the code. So we were playing with that more than I meant to, but so I did int number in number 2. So I prompted them for both the number of loops and the number they want to get the exponent for. So number 2 equals times equals number 2, and then I write line number 2. This one is still number. Okay. And that one I should comment. So it seems to be working now, except that it's really easy to override the limits of an integer. One of the things you could do is, if we did,
If we did a double.
well, I wouldn't do a double. Let's try big int. Oh, how do I do that? There is a big int, but how do they declare it? Is it int 64? Doesn't, no. Right? I was just going to look real quick at the data types. Let's do this one instead. Because I know you need a bigger, maybe it's just big. Is it big integer, big integer, big integer? Let's try that. So actually number can be int. number 2, is it big integer? No, it doesn't like that. Yeah, but it wasn't doing.
Looks like it's big integer, and then in parentheses you put something else.
Okay.
Big integer byte, big integer decimal, big integer double.
Oh. From double console. Let's see if we got. This is actually a link, but let's look at just data types. Byte, byte, short, unshort, long, long, double, int. Yeah, long is what I want, not big int, but long.
Is there a way if you want to just replace, like, let's say you have the hint up there, like a command where if you just change it, it'll change it everything below? That's.
Well, if you wanted to change them all,
Mm-hmm.
I mean, you should be able to do find seek, find change. So if you go to edit, there is find and replace.
Okay.
So with long, if I do, and let me zoom this up again. And then what we'll do is we'll do a little exercise here.
Manage to overrun it again because it's long.
Does it?
Yeah. Just at a higher number of places.
Mine went, it depends on how many loops you go,
Well,
probably.
yeah.
Yeah, but putting like 999 and it's not else.
Oh, yeah. Exponents rise really large. I mean, really fast. I don't know that there is anything much bigger than the 64-bit. I don't know if there's 128 big. That might be what the big int method, the object is for, is to take a integer and make it even bigger than the 64-bit. 64-bit's pretty big, though. But one of the things, and this is actually useful to know, wasn't part of what I was going to talk about today, is that if you overrun value like an integer, if you go beyond its precision, it just returns garbage. And so it's really sometimes difficult to know that. The fact that it was a minus number is a hint. And they might do that on automatically, make it a negative just to let you know that they're returning garbage. But if you were expecting negatives, that could be a problem still. Yeah.
I'm doing an error for that number 2 along that line.
You did?
Yeah.
With a lowercase l and a, what kind of error?
So it's kind of implicitly convert type long to int.
Oh, so when you change long dot parse, it also has to be long up here.
Oh, I got you. Thanks.
Let's look at the pure exercise thing. So I think it's up here. So I'm going to go to, let me unzoom a little. Now, the pure assignment is basically the for loops. And the idea is, again, just to work on it. Anything you turn in is fine. And it just says create a loop that returns all the odd numbers between 1 and 100. The groups for this, if we go to people, and again, there's a pure for loop, and you might have to scroll way down to find that. My setup is a little different than yours, but if you want to join one of the pure for loops, and then just do this, try to make that loop together, and then we'll talk about it briefly, and then we'll talk about while loops. And then we'll be ready when Thursday will be an open lab to work on the next assignment with these.
Tuesday.
Thursday, right?
Thursday.
Yeah.
Pure for loop one.
Yeah, so go ahead and kind of just join whatever groups you want to.
It's called peer class.
No, not pure class. It's pure for loop. As I said, you might have to really scroll down there.
Oh, yeah. Down here.
So what you want is pure for loop. And I know that the way that the student look at this is it just goes down. You just got,
Oh,
It's like pure for.
yeah. And then
so you want to do pure for.
I just doing stuff.
You can do these by yourself, but I just think it's good to have a discussion about it. And as I said, for these, we'll discuss it, but basically it's just, my brain is,
Should it have a list of our names?
it should have the names in it.
So this could have pure for loop one.
You might have to refresh.
The one we're gonna do.
That's
I
not
just,
me.
I was practicing.
Oh,
So I just did it.
Right.
But I haven't.
that's a good question. Yeah, let's give this like 15, 20 minutes, and then we'll talk about it. It may not be that long.
Are we doing the first one?
We got Jessica.
Oh, right.
I was still looking at it. I remember you said it's like, so I will understand like how.
Lets me look at that. So it's assignment 4.
Or it's the third part
It's
of it.
like what you're saying.
Yeah, it's like exactly.
Understand pure for loop.
And what I did to get on yours was the number divided by 2.
So I say, like, create for them, says how many times would you like to loop? You say, yes, you say 6 times, it counts down 1, 2, 3, 4, 5, 6.
Right.
And would you like to continue? Yes. If it says yes, go back to the beginning.
So what I'm thinking of there,
That's a fantastic question.
so I'm thinking of a loop.
That's okay.
Give me choices and I will give you.
So let's just go like
You're going there, let's just do it on yours.
int
Just purely.
counter equals 0. Okay, so while, so I said while.
Well, counters.
Well, this
They
one-
have to put in console, like, right line, how many times would you like to loop, and then while.
Well,
and then-
actually, with the while you loop forever, right? Until you say stop.
Okay, but this one is, you gotta go through the number of times they want.
Right, so that's what I was gonna do. While,
And starting with 1.
I don't know what we want
I
to
haven't
call it.
written it out, but I know how it goes.
And then I just did.
Choice.
That's a good one. Well, choice, so let's do
It's the pure exercise. It's the odd.
choice equals go or something. String choice, right? Well, choice, not equal,
you've already
or
done the odd
since it's a
number.
string, you could do not dot
Or.
equals stop. I mean, you could do a not equal sign too. Counter plus plus,
Maybe that's
console
another
right line.
Sure. I did, well.
So it's going to tell how many loops you're doing, right?
Okay.
And then basically
I don't really care.
console right line.
Yeah, that's right, you mentioned that, I remember that.
Would you like to stop?
Yeah, stop,
And welcome.
continue, or stop to end, or whatever you want to
Stop
write.
to end, yes to continue.
Yeah. You could actually, the way it is, you could write anything to continue.
But this is, I have to ask them, but I have to have an input of yes here. So if yes, then continue. If no, then the program.
Oh, right, so I was
That's okay.
confusing these two. Yeah, so what you want to do is while, so what we want to do is yes to continue, no to end.
So this one is actually the second, the part 4 here.
Right, so here we want to just say yes. And then this one, we still want to do the counter in there. And then instead of that, we want to say no. And then say no, yes to continue, no to end, right?
Let's try one, yeah.
No, we do need to.
Battle space.
Well, wouldn't this be while the choice stays yes? Then it.
Oh,
you-
right, yeah, you're right.
Okay. So while choice equals yes, counter plus plus, right line count, this will put that print out the counter. And then
Right,
console right line.
yes to continue, no to end, and then
So
you,
each time it'll loop, it'll say one, yes to continue, no to end. If they say yes, okay, two, yes.
Right,
And then when they hit
and-
no, it'll just go, it'll pop out of it.
right, and then you just do a choice equals a console read line here to get their choice each time.
Okay, read line, and then, okay. Cool. That makes total sense.
So.
My description may not. be.
No, it did. I'll be back in a minute.
Okay. I'll be right back. I'm just gonna use the restroom.
Oh, it gave me the same. Yeah, I think because here,
No.
here, it's saying, if the number divided by
Don't forget to
two.
put
Oh,
in,
yeah.
pressing a key. Give that a shot and see what we get.
Obviously, I haven't explained.
Yeah, that's it. That's no deal. All right, cool.
Okay,
He's
so
got one with the wild.
we might need to do.
Oh, because we have a read line, but we didn't enter anything and we just have a program.
Oh.
All right.
That's it?
Oh, yeah, I think you're already in the green screen.
Yeah, it's straightforward.
Yeah,
No, it's just.
I wasn't sure. I was like, how do I remember?
So.
Yeah.
Yeah, because that's the first of its space.
Yeah, exactly. That's all it was.
Yeah, I mean, I never really so good in time all those. But yeah, I just want to say, I starts at 1, and then I is going to be less than 200, and then, you know, just I plus 2 to 1, so yeah, I was like, yeah, just adding 2 to 1, so.
Oh, because you need to say.
That's what he wants us to do a while.
We'll do a while loop in a minute.
Oh.
All right, sounds
So
good.
create a while loop.
We'll talk about the while loop in a minute.
Oh, okay. We just finished the.
Okay, how many are done?
Well, we're done.
How many still need a minute? All right, let's give it just a couple more minutes and then we'll talk about it. And then we'll do the while loop.
See you for the weekend.
Yeah, man, I'm ready for the start.
Yeah, I think that's almost gonna be a while, but I was a little bit excited for it. It's okay.
I like to go out.
Yeah. Again, nobody.
So basically, I'm saying, if number is odd,
Did you
then.
want me to
Right.
send that to you?
Yeah, that'd be great, actually.
Yeah.
So.
If you want to use your file, just tell me.
No, that's fine.
The Cardinals look like they're back too.
Yeah, I wasn't watching. They're always a tough team, though. Everybody, I always do those problems.
Yeah, they're the only thing I worry about. It's St. Louis, that's it. It's-
Yeah, I guess it's St. Louis though, right now.
Yeah,
that is.
sorry, yeah.
Oh, it's all good. Yeah, for some reason, I'm not even good. For some reason.
Where name it wherever you want. Here. For in I, so I'm saying for this computer. And I named it I.
So that guy saying that, put on quarterback.
No, he's in the,
You can do whatever.
So he's not good. Oh, he is doing really good. Oh, that's really good.
Aha.
He was throwing the ball for it.
Makes it easy.
So if you're using it down here, you can.
Jason?
Yeah.
It wasn't good at first.
So are we ready or you guys want a little more?
Although technically, I could have also finished the email as well. To your school email. Then you have to work out one.
Yeah.
So does anybody want to like come in up and do what they did or just tell me what they did?
Yeah, I'm willing to go up there.
Okay.
I'm willing to step on up.
All right. You can't get this wrong. So I just give you the points.
All right, so I got help from all my people over here, but if I started out with I equals 1 because I is an odd number, and then I did I is less than or let's tell me it's if I is equal
You
to.
know why it's giving you a problem? You need to write in front of I.
Oh, all right, yeah, I forgot to do
So
that.
you try to be helpful.
Yeah.
There we go, yeah, a little mistake. And then I just increment it by 2 here, so I just do a little plus equals 2,
Yes. Today is.
and then I do console dot right line.
Okay, that's one way. That should work. Actually, if you run it, it'll just flash by.
Yeah.
Oh yeah, I need to pull a
You can
toolbox
drag it
out.
from over here.
All right, you got the.
Down below.
There we go. All right.
On the one we turned in, we. Right there, yeah.
No, we did. I pulled it out. There we go.
Okay, this is one way. Run it and go ahead and look.
So yeah, there we go. We got 1, 2, 3.
They're all
All odd numbers.
Yeah, we did.
Yep.
So that's one way. Did anybody else do it differently? Because there's another way to do it. That does work. You could. I mean, one of the other options, a little more complex. I'll just copy. I think this is the simplest solution by far. You could do, let's say we start at 0 and we just do a plus plus. Or even 1. Doesn't matter where we start, 1 at plus plus. One of the things you could do, and as I said, this is a lot more complex, is you could say if I modulus 2 equals 1, right? A double equal. So if there's 1 left over, then it's not an even number, right? Then you could say console. So this has exactly the same result as the other one. It's just a little more complicated to think about it that way. Does that make sense to you? So if you divide the number by 2 and it has a remainder, then it's an odd number, right? Because even numbers are by definition any number that's divided by 2 with no remainder. So this would return all the odd numbers. So will this. They both work. It's just 2 different ways. Did anybody else have any other ways of doing it? Questions on that? Typically, when I find if you have trouble, it's because you're being more complicated than you need to be rather than less. But no questions? It's okay to have questions. If you haven't done this kind of stuff before, it's a little alien. absolute silence, so I guess that's okay. Off the top of my head, I can't think of a third way to do it, but I'm sure there is, probably. All right, let's do a while loop real quickly. Are you guys okay with for loops? Okay, so the thing about for loops is that these are counted loops, right? You can use a variable, like where instead of when you want to say how far you want to go, you could say less than whatever the variable name is, like number. You can actually do a variable for this too. Where do you want to start? You could have a question, where do you want to start? And you can use that as a variable too. Right, so any of these terms can be replaced by variables if you want. But nonetheless, it is a counted loop. It has a finite number of loops it is going to do. So I'm going to do a new project. I'll save this. So I'm going to do a new project. I'm keeping this kind of small. If you want me to zoom it, I can. I'm just going to call this while loop example. You might notice I don't have really creative names for a lot of these. So the difference between a for loop and a while loop is that a while loop will go forever until you give it a condition to exit. It isn't counted. The number of loops aren't counted. So let's do, I'm just going to do a real quick I think I'm going to do I don't want to do your assignment, so let me think if I want to do this. I'm going to do like a quick menu. So I'm going to think about, so I need something for the loop to continue. I'm going to say choice int choice equals 1. I'm going to say while choice not, I want an exclamation, not equal, how many choices do we want? I'm going to say 4. Okay, and then we do the loop. So I'm going to just like a simple, what?
Oh, no. 1 equals.
It's an exclamation point, which means not equal 4. So I'm going to do console write line but I'm trying to think of what this is going to be really dumb. So what, I just need something to put into these 4 things. Normally what I would do is I'd be calling different methods or different parts of the program, but I don't want to do that. What would I put in the second? If I say hello in the first one,
Is that say, well, choice does not equal 4?
yes. Yes, exactly. So this will be really dumb, but just to get the idea. I think one of the things I'm going to do in here, you haven't seen this. Does anybody know what this does? Yeah, it's a tab. /n is a break line, and these are tab. So they should come out looking about the same. And then I'm going to do console right line goodbye. And we'll do that as /t:4. So 4 is what we exit on. And then I'm going to do console right line enter your choice. And then choice, which we declared up above, is equal to int, and you can do a try parse if you want, but I'm keeping it simple. Console okay, so I'm going to do, this is going to be complicated, I'm going to do a switch in here. And the choice, it'll be switch on choice. This is where switches are really good, where it has to equal a value, right? So I'm going to do case 1. Actually, it's case 1 colon console right line. This is more complicated than I meant. Hello 1. Break. And then I'm going to do, I'm going to copy that. And this will be hello 2, and it's case 2. We'll do the same for case 3. This will be case 3, hello 3. And then case 4, will be goodbye. I'm also going to do actually, I don't know that I have to. It's going to go out of this. It'll actually, and that probably will never see the goodbye. We might fix that in a minute. Anybody know why? I'm curious if we'll see. I'm going to put a default, and I'm going to do console right line. This one I'm just going to say invalid choice. I'll break. And then outside here, I will do the console, the press any key to exit, which you don't really have to do in a sense, because this loop is going to go until I say number 4, until I type in the number 4. Right? Because the choice is going to be based on my input. When I enter 4, I need a semicolon after break there. It will come back to the top of the loop. It'll see that it is no longer not equal to 4, and it will exit the loop. The loop will keep going as long as I don't type in 4. I can type in any other number. But as long as I don't type in 4, it'll keep going. Questions? I see people with questioning words. This is probably more complicated than we needed for a while loop. The trick with a while loop is that it will loop forever until this condition is met, right? And then in this condition, it'll loop forever as long as choice does not equal 4. There are lots of times when you want to keep looping. If you're building a game or something, you want to keep looping until they choose to exit, right? So this is you can build around it. You can also use this. This doesn't matter so much if you're working with forms or web pages. It's mostly in the console. But you can create like a little mini. That's kind of what I did here. This is more complicated than anything in your assignment. Yeah. Sure. Yeah.
On the when you have hello \T for the tab.
Yeah.
Does that have to be right after the word?
Well, it's just if you want to get the spacing exactly. I was trying to get the spacing the same.
Okay.
I don't know that it will be, but that sometimes I have to play with that. So the tab will occur immediately. Well, actually, you know what? I probably want the tab after the colon anyway. Does that make sense? It does. It makes more sense to do it after the colon. Because what I was thinking in my brain, but not what I was writing. Oh, I still did that one before. Let's see what it looks like, and then I'll come back to it. We'll probably walk through this one like we did the for loop. Okay, so I'm going to, ooh, goodbye is way over there. Because it's long enough that it did a different tab. One way I could do that, I suppose, if I did all of these as double tabs. You guys don't have to do this. Whether it looks nice or not really doesn't matter. So I'm going to zoom this up. So there's my menu with the choices. So if I enter my choice, let's do 1. It says hello 1. Oh, and then it says press any key to exit. Why is it doing that? Did I put it inside the loop? I did. Thank you. You don't want this inside the loop. So I want it between here and there. What?
Do you need it?
Well, you don't need it, except I want it to be able to say see the goodbye.
Okay.
And you wouldn't see the goodbye because you would exit so fast.
Oh, okay.
So let me run it again. So I'm going to enter my choice, and that's, so I'll do 1. Gives me the whole menu again, right? It goes to the top of the loop. I'll do 3. I'll do 7. It gives me invalid choice, and it loops again. And if I do 4, it'll say press any key and exit, and it exits. 4 exits the loop. I will walk through this with, I'm going to put the break in there. And I will zoom up a little bit so you can see the thing. So when I start this, it breaks right away. So I go, this says choice is equal to 1. So I go down here, and then I can choose, it's basically just going to walk through here. And it's going to ask me to make my choice, which I will do 3. All right, so when I make my choice, it says 3 here. F11 comes down, goes down to 3, all right, because it goes to the case that matches. F11, it'll come down here to the break, so it'll leave the switch, it'll come down here, and then it goes back up to the top. Choice is equal to 3, so this is still true. It actually says true there. I don't know if you can see that. So if I do F11, it'll give me the whole menu again. And then it'll ask me to enter. This time I'll do 4. I'll enter. Let's go back here. So choice is equal to 4. F11 goes down to 4, says goodbye. Breaks out up to the top again because it has to compare this. And it's false now. Choice is not, the fact that choice is not equal to 4 is false because it is equal to 4. So because of that, it'll pop all the way out of the loop. It'll come down here and it'll exit. That makes sense? A while loop just keeps circling until this condition is met. And so it's nice. I mean, one of the things you can do here, I'll show you one other use of a while loop real quick.
Question.
Yeah,
Will the press any key to exit? Is that outside the loop?
that is outside the loop. I originally put it in the loop because I wasn't paying attention to my curly braces. So we're starting to get a lot of curly braces, and I think I'm going to add another one to make this even worse. So this is the end switch. End loop. End main. End class. End namespace. So we have lots of ends of it. Do you guys you want me to zoom down a little? And if I'm in your way, let me know. I know sometimes I stand right in front of the people right here. How far do you need it up more? I'm going to do one other thing. I probably should do it as a separate thing, but I might do it inside here. Because you can have loops inside of loops, just like you can have ifs inside of ifs. Questions on that so far? Does it make sense? Don't worry if you don't have all the syntax in your own head yet. The idea of a while loop makes sense. Yeah.
So is it just good form to always use the switching when you're working with your the loop?
You don't have to. You can use ifs and if else. The thing that switches are really good for is when you have really distinct choices like this, right? So I'm like setting up a menu. Switches are good for that, but it would work just fine with an if. I'm not really sure which is more efficient. I actually suspect in this instance a switch would be more efficient because it takes less resolving. But that being said, an if statement would work the same with statements. If you need to have any kind of like you need to judge a range of values. So if it's between this and this and this and this, you have to use an if statement for that. Switches only allow, it has to be one or not one, right? It only allows a single possibility for each of these cases. The case is that it is one. If it's not one, it'll go look for another case. Case is that it is equal to 2, then it'll do it. It'll just test each possible case, and then default catches anything else. So I just wanted to show a switch in use. I actually use them very seldom. Switches are things, this might be one of the few times when I actually use a switch, but there are times when your choices are fairly distinct and it can work just fine.
You need the break after the default.
You do. You would think you wouldn't, but you do. It'll throw an error if you don't put it there. I'm going to do something here that may confuse things, and I don't want to confuse things, so you know how we have int parse? What would happen if I entered something not an integer? Yeah, the whole program would crash, right? I can show. Let's do. So I'm going to zoom up for the console again. So my choice, let's say I say, I'm going to do 3.5. I'm kind of in between whether I want hello 3 or quit. It isn't like it's just going to, it actually crashes the program. So we did this before. I want to show you how you can do a try parse with a loop. That will make it so that you don't allow them to continue until they enter a valid number. All right, so let's change this. I'm going to zoom down a bit at least. Let's change this to a try parse. Do you guys remember what we have to do to choice here? We have to make this a Boolean, right? So I'm going to do bool, bool, and I'll just call it good choice. As I said, I always have trouble naming Booleans. This needs one other thing. It needs a comma out choice. So it'll assign the value to choice. I'm going to name bool. I'm going to do bool good choice right here. I'm going to make it equal to false. And I'll just get rid of the bool here. And what I'm going to do is I'm going to put this inside of a loop. So I'm going to say while good choice equals false. So this will loop until it isn't false anymore. So until they enter a good number. And then but you want to tell them that. Actually, so I'm going to move this inside here.
You can't say, well, not good choice. That won't work.
Yeah, you actually could. You could actually say just, this is equivalent. It's exactly the same thing. You guys have a preference? This is exactly the same thing as equal false. It probably would be nice of you to say if not good choice, enter I mean, telling them why they're being stuck in an endless loop here, right? So what will happen with this loop, and this is a while inside of a while, so I know it's a more complicated, nothing in your assignment is anywhere near this complicated, but we get going, I get going. So this is going to do the try parse, and basically it's going to take their choice. If their choice is good, it's going to ignore this, and it's going to exit the loop, and it'll just go down to the other stuff. If they write something bad, it'll say, please enter an integer 1 to 4, and it'll come back up here to enter your choice. And it'll keep doing this loop until they enter a value that is, it doesn't have to be 1 to 4, actually, it's only going to test for an integer. But, I mean, you could do it for an integer too. So, and I made it equal to false up here so that it will loop, right? So that it'll loop at least once. Let's try that. And then I will put this code online and I'll comment it. So I'm going to enter.
It looks like you're checking not good choice twice.
Well, I'm only checking it. I am. This one I'm checking to give them a prompt. The thing is, if it's good choice here, it's still going to do. If it's not, it's going to come up here. This is just, they only get this prompt if it's bad. It's only going to loop if it's bad. But if they do a good choice here, you don't want to give them the prompt again, right? So I am testing for it twice, actually. All right, so if I enter a choice 3.5, it'll say, it actually didn't give me, oh yeah, enter an integer 1 to 4. Enter your choice. And let's say I write the word 3. Enter an integer 1 to 4, you know. So it just keeps going. If I enter garbage, it's still going to say enter an integer. It just keeps, it isn't crashing though, right? It just keeps going. So when I finally say 3, then it gives me hello 3. And when I do 4, it'll let me exit just like before. So this is just, if you really, when we get better at programming, you will want it so your programs don't crash. You know, and you don't want to get it so that, like before we had the loops, if you wanted to, you could do the try parse, but basically you could give them one more chance, and if they fail that, you just have to say goodbye.
Is the try parse what allows it to be decimal?
The try parse, so the try parse doesn't crash if it can't parse. What it does is it returns a Boolean, true or false. If it returns false, then actually, I'm not sure what it does with choice. I think it gives it a 0, but it basically it returns false. So and it doesn't crash. If it does parse, it returns true and it assigns that value to choice. So try parse is a nice thing in that it keeps it allows you to not crash when somebody enters something wrong. One of the things, so you can get a program that works really well as long as everybody does what they're expected to do. But when they enter things that are unexpected, you need to be able to anticipate that and deal with it in some way, unless you want your program to crash. And this is true even in, now in a form, you don't really have to loop because you can just say that's not a valid mess, you know, that's not a valid entry, and you can just clear out the form, the text box or something, and put the cursor there and basically make them re-enter. And you can do that forever until they enter something that the form will accept. So you don't have to loop there, but in a console, this is the only way to really handle it. So we have, and then what we're going to do is just a much simpler thing. A loop, I'm actually going to show you one other thing real quick before we do the wild pure exercise, and then we'll be done for today. A while loop is different than a for loop in that it doesn't have a set number of loops, right? It just will keep looping until the condition is met. So this will loop as long as the number doesn't equal 4. You can do it forever as long as you don't enter the number 4, right? This loop, again, also will loop forever as long as the choice is false, right? So as long as they're not entering a good number, it'll just keep looping forever. But as soon as they enter a good integer, then they're done with this loop, and it'll go on to the rest of the code. Does that make sense? Maybe if it doesn't, let me know. As I said, there aren't any, this is, this stuff can get a little subtle, especially now that we have a loop inside of a loop. Just like with if statements, there is a limit. You can only have 255 embedded loops. But anybody that would do that would be insane. The reason why for 255 has nothing to do with logic. It has the way they count loops. They count it in a byte, and the largest byte value is 255. It's a compiler rule. It has nothing to do with logic. Logically, if you have more than if you had a loop, if you had more than 3 embedded loops, I would start to question what you were doing. Yeah, I mean there are legitimate cases where you can do that, but it gets to be problematic after a while. Also, performance. Loops inside of loops are notoriously bad performers, especially if you're dealing with data. In this case, it wouldn't matter much, but if you had a lot of data that you're processing in the loops, it could be a problem. All right, I want to show you one other kind of loop, which is just like a while loop. I'm not going to spend a lot of time on this. It's a do loop. I'm just trying to think of, so I'm going to do, actually let's do string continue. Is it while here? I think it is while. It's pretty close to the assignment. I'm having trouble typing. There. Oh, you know what? Continue is not a good keyword. Can you tell why? I mean, not a good. It's a reserved word. All right. So then inside of here, I would just do console. I really can't type this morning. I'm going to do one other, that's a semicolon, not a, and then I'm going to do one other thing. I'm going to say continues equals continues to lower. Anybody know what that does? Let me pop that up.
Makes it all lowercase.
It makes it all lowercase so that you can type yes however you want or no. So what's the difference between this and a while loop? It's only one difference. It's a minor difference, but it can make a difference in your code. So, well, the big difference is, notice the conditions at the end of the loop. So when you have a while loop, the conditions at the beginning of the loop. So what that means is that if I wrote this as true, it would never enter this loop, ever, right? Because the condition was false already. So if I say good choice equals true, and this says it's while it's false, basically. So because it's not false, this loop will never happen. All right, if that condition isn't met at the beginning, then the loop will never happen. The do loop doesn't test the condition until the end of the loop. So a do loop is guaranteed to always run at least once, because it'll run through it and then it'll test the condition at the end of the loop. Right, so a do loop always happens once. A while loop might never happen if the condition isn't met at the beginning. That's the only difference between them. The condition is at the end, whereas at the other one, the condition is at the beginning. Is that, I mean, so I use do loops when it is really important that it goes through the loop once. But they behave the same. So in this one, again, what we do is we just have to enter yes or no. And basically, the way this is set up, because we did it on the yes for continue, anything you type other than yes will kill the loop. So I will run it again. And then we'll look at the, am I running? There it goes. Let me, all right, so I still have the choice. So let's kill that part. Continue yes or no. And I'll say, just to show you that it works, I'll say yes with a capital Y, and so it continues. And I'll say yes with all caps, and it still continues. And then I'll say no, and then we're done. All right, yeah.
So how would you do it how would you do the while part where, or so that they have to enter something specific to make it, you know?
So well, you could say while,
like they don't answer yes or no, it tells them you need to enter yes or no.
Right, so if you enter anything else, it continues, right? So you could do, I mean, you could do a loop inside of here that says if it's not equal to yes or not equal to no, then keep going. One of the things you can do, instead of having a yes to continue, continue while not continues equals no. Right? If I did, I keep doing the one. Now this is the opposite in that it will continue no matter what you type in until you say no. It'll just keep going no matter what you type in until you say no.
Okay, so that would be, okay, that's okay.
Whereas the other one will stop unless you write yes. So it's sort of whether do you want them to loop forever until they say the right thing, or do you want them to exit if they don't write the right thing. I'm going to put it back the way it was just for now. Get rid of the not. You can negate anything with an exclamation point. Equals, as I said before, is good for strings. Equal works in C# for comparison. It's just that they in their notes, they say they don't promise 100% that it'll always catch, the equivalence. Whereas equals does it's specifically a string comparison. When you get into Java, equal doesn't work with strings and you have to use equals. But in C# you can do equal, yes, if you want. All right, so let's look. I'm going to save this. And then let's look at the last. So there is a, let's do assignments. And there's a peer assignment on while loop. Well, I did one for while loops and, instead of just loops, I'm not sure. So this is a lot like what we just did. Create a while loop that allows the user 3 choices, option 1, option 2, and then returns, it quits and returns goodbye. It's almost exactly what we did. You guys want to, I guess, do it just so that you can have a little practice of it, and because they need to give you a grade for it. So this is the peer exercise while loops, which is pretty much what I just did on the screen, except that I did it more complicated. Don't make it as complicated as mine. And then the groups for that, there should be a peer while group.
Oh, yeah.
Peer while. You have to scroll down a lot, yes. So do that real quick, and then we'll call it a day. I will give you an open lab on Thursday to do assignment 4. Unless you're done.
I'm not done. When I was putting the Boolean thing in this, I screwed it up.
Tier 1. 2 other people heard that.
Me back out.
I did. That's true. Although there's a little different. Yeah, choices. I guess maybe we'll go with switch. Is it Tier 5? Yeah.
I want to pure this.
Also, I had to do something else. My computer or yours.
Here, yeah, okay.
That's good. Here, you want to go down to here. Here, wild. That's great.
That makes much more sense. Thank you.
Okay. Any other?
And then-
I was in the middle.
So I think this one is pretty much like you said,
And the other one I got.
and I didn't go as far.
So while you do this, I'm going to post these on the blog, and I'll probably stop the video. And then we'll talk about it in like 5-6 minutes. I know that may not be enough time, but
That's what's